Hello, in this lecture we'll find out the length of line segment X using two different methods. In the drawing we have a semicircle inside a quarter circle. We know that AO equals to 6 units. AC is tangent to the semicircle at this point, and we want to find out the length of side AC that is actually equals to X. So we start with the first method, and we will define the point of tendency of tangent AC with this semicircle as point D. And we will define the center of this semicircle as point P. AO is the radius of the quarter circle because of the fact that point O is the center of the quarter circle and point A is the point on the quarter circle itself, and this is exactly the definition of a radius. So the radius of the quarter circle equals to 6 units, and OB is also the radius of the quarter circle, that is to say it is also equals to 6 units. Here OB equals to 6 units. It's the radius of the quarter circle, and we also know that the diameter of the semicircle OB is equal to 6 units, and the diameter is twice as large as the radius. So if the diameter of the semicircle equals to 6 units, it means that the radius of the semicircle will be equal to 3 units. So OP equals to 3 units, and PB is also equal to 3 units. We'll join points P and D together by a straight line. Here line segment PD is also the radius of the semicircle because of the fact that it starts from point P, that is the center of the semicircle, and ends at point D, that is the point of the semicircle itself, and this is exactly the definition of a radius. So PD will be also equal to 3 units. It's the radius of the semicircle. We join points A and P together by a straight line. And we also know that angle AOB equals to 90 degrees. This angle equals to 90 degrees because AOB is a quarter circle. Therefore, this angle must be equal to 90 degrees. And actually, triangle AOP, the right triangle AOP, is congruent to the right triangle APD. But before that, I will present to you a new rule. That is actually rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. The lengths of two tangents from a common external point to a circle are equal. So I read rule number 1 again. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is that if we have this point P is an external point in relation to this circle because of the fact that point P is not located inside this circle nor on this circle, but it is located outside of this circle. Therefore point P is an external point of this circle. So if from point P we draw two tangents to this circle, we define the point of tendency of the first tangent with this circle as point A, and we also have a second tangent to this circle. We define the point of tendency of the second tangent with this circle as point B. So according to rule number 1, the lengths of two tangents, that is to say, the length of the first tangent is PA, and the length of the second tangent is PB. And according to rule number 1, the lengths of two tangents from a common external point, that is to say, from point P to a circle to points A and B, are equal. That is to say, PA is equal to PB. Again, according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, PA equals to PB. So whenever you draw two tangents to a circle from a common external point to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA will be equal to PB. So we can implement rule number 1 in our drawing, because in our drawing we have the common external point A, and from the common external point A we have two tangents to this semicircle. The first tangent is tangent AO. Tangent AO is tangent to the semicircle as point O. Point O is the point of tendency. And we have the second tangent, that is tangent AD. Tangent AD is tangent to this semicircle as point D. Point D is the point of tendency. And according to rule number 1, the lengths of those two tangents are equal to each other. That is to say, AO equals to AD. I write it down. According to rule number 1, AO equals to AD. According to rule number 1. Okay, but according to what is given as the question, AO equals to 6 units. So I can write here that AO equals to 6 units. And from this equation, 6 equals to AO equals to AD, we derive that AD is also equals to 6 units. AD equals to 6 units. So here, AD equals to 6 units. So you can see from the drawing, X equals to AC, that is to say, it is longer than AD. Okay? X is not AD, but it's AC. And it is longer than AD, that is 6 units. That is the line segment that we are looking for. So we found out that AD equals to 6 units. Actually, as I already mentioned, triangle AOP is congruent to triangle ADP. This triangle, those two triangles congruent to each other according to side rule. I write it down. Triangle AOP, this right triangle, congruent, this is the sign of congruent, to triangle ADP, this angle according to angle, the side, according to side rule. Side rule. Okay, I repeat again. Those two triangles can go into each other according to side rule. Here, AO equals to AD equals to 6 units. In addition, AP is a common side that belongs to both triangles, so AP equals to itself as a common side, AP equals to AP is a common side that belongs to both triangles. And finally, OP equals to PD equals to 3 units, both are radii of the semicircle. OP equals to PD equals to 3 units. They are the radii of the semicircle. They are equal to each other. So we actually found out that those two triangles can go into each other according to side rule. Okay. Therefore, hence, we can conclude from the fact that those two right triangles can go into each other that those two angles are equal to each other. Okay, so angle OAP is equal to angle PAD, this angle, according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore those two angles that are defined as corresponding angles will be equal to each other. So if we define angle OAP as theta, then from this equation, theta equals to angle OAP equals to PAD, we derive that angle PAD is also equals to theta. So both those two angles are equal to theta. Okay. In the next step, we will focus on the right triangle, triangle AOP. This right triangle AOP. In triangle AOP, you know that tangents theta, in this right triangle, tangents theta equals to OP over AO. OP over AO. OP equals to 3 units. And AO equals to 6 units. So in conclusion, tangent alpha equals to 3 over 6, that is 1 over 2. Tangent theta equals to 1 over 2. Or 1 half. Okay, tangent theta equals to 1 half. In the next step, We will join points O and C together by a straight line. So what is the definition of line segment OC? Line segment OC starts from the center of the semicircle and ends at a point C. Point C, that is a point on the semicircle itself. And this is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to 6 units. Okay, OC equals to 6 units. So, in the next step, we will implement the law of cosines in triangle AOC. The green triangle, triangle AOC. First of all, I will repeat on the law of cosines, and then we will implement the law of cosines in this green triangle, triangle AOC. Okay. So what is the law of cosines? I mentioned it in the previous lecture, so I will repeat on it shortly. So actually, if we have triangle ABC, that could be any triangle, this is triangle ABC. We know that side AB of triangle ABC equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length. And the angle between side AB and side AC is theta. Then, according to the law of cosines, we will get that C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay, this equation is true in any triangle. Now we will implement the law of cosines in our triangle, the green triangle, triangle AOC. This is the law of cosines. I repeat again, in any triangle, here C squared equals to A squared plus B squared minus 2 times AB times cosine theta. So I will copy the triangle AOC in a new page, and we will implement the law of cosines in this green triangle, triangle AOC. Okay. This is triangle AOC. We know that side AO equals to 6 units. Side AC is the side that we are looking for, that is X. Side OC as I already mentioned, it is equal to 6 units. This is the radius of the quarter circle. Angle OAC equals to 2 theta. So, according to the law of cosines, we get that this will be question number 1. We get that OC squared equals to AO squared plus AC squared minus 2 times AO times AC times cosine 2 theta. So here OC equals to 6 units, as you can see from the drawing. Therefore OC squared is 6 squared, that is 36. And it is equal to AO squared. AO is also 6, so AO squared is 6 squared, that is 36. Plus AC squared. AC equals to x, so AC squared will be equal to x squared. Minus 2 times AO is 6 times AC is x times cosine 2 theta. Okay, so here in equation number 1 we have 36 on both sides of equation number 1, so 36 will get cancelled. And we left only with 0 equals to x squared minus 2 times 6 is minus 12, so this expression equals to minus 12x times cosine 2 theta. We will add minus 12x cosine 2 theta to this equation, and we will get that according to equation number 1, 12x times cosine 2 theta equals to x squared. We'll divide this equation number 1 by x. I will remind you that x is the line segment that we are looking for. It must be a positive number, it can never be equal to 0. That is the reason that it is allowable to divide equation number 1 by x. Because of the fact that it can never be 0, it is a length that it must be a positive number, of course. So we'll divide the equation number 1 by x, and we will get that according to equation number 1, 12x over x is 12. So 12 times cosine 2 theta equals to x squared over x is x. So we found out that according to equation number 1, 12 times cosine 2 theta equals to x. Now the only thing that is left is to find out the value of cosine 2 theta. Okay? And actually we have a trigonometric identity for cosine 2 theta. According to the following trigonometric identity, we will get that cosine 2 theta equals to 1 minus tangent square theta over 1 plus tangent square theta. We have already found out that tangent theta equals to 1/2. Okay? Now we can substitute tangent theta in the trigonometric identity by 1/2, and we will get that according to this trigonometric identity, cosine 2 theta equals to 1 minus tangent theta equals to 1/2. So tangent square theta will be equal to 1/2 squared, that is 1/4 over 1 plus tangent square theta. Again, tangent theta equals to 1/2, so tangent square theta is 1/4. So in conclusion, we found out that cosine 2 theta equals to 1 minus 1/4 is 3/4, and 1 plus 1/4 is 5/4. So here we have 4 on both sides in the numerator and 4 in the denominator, so 4 will get cancelled, and we left only with 3/5. In conclusion, we found out that cosine 2 theta equals to 3/5. Now we can substitute cosine 2 theta in equation number 1 by 3/5. We will do it now. According to equation number 1, 12 times cosine 2 theta equals to x. X is the line segment that we are looking for in this question. So we'll substitute cosine theta in this equation, equation number 1, by 3/5. We'll do it now, and we'll get that 12 times cosine 2 theta is 3/5 equals to x. So in conclusion, we found out that x, the line segment that we are looking for in this question, is 12 times 3, that is 36/5. 36/5 is 7.2. That is to say, x equals to 7.2 units. Okay, x equals to 7.2 units. And that is the answer to the question. Here, x equals to 7.2 units. That is actually equals to AC also. So AC equals to x equals to 7.2 units. In the next step, I will present to you how to find out the length of line segment AC that is equal to x according to the second method. In the second method, we will use all the things that we already found out in the first method. Here we defined the point of tendency of tangent AC with this semicircle as point D. The center of this semicircle is defined as point P. OP equals to 3 units, PB equals to 3 units, PD is also the radius of the semicircle that is equal to 3 units. We join points A and B together by a straight line. We have already found out that, so this angle equals to 90 degrees, angle AOB equals to 90 degrees. And we have already found out that triangle AOP can go into in this AD equals to x, according to 6, according to rule number 1, of course. And we have already found out that triangle AOP can go into triangle APD according to side rule. I write it down. Triangle AOP, this triangle can go into triangle APD, this triangle, according to side rule. And from the fact that those two right triangles can go into each other, we concluded that those two angles are equal to each other. Okay, angle OAP equals to this angle, that is angle PAD. And if one angle equals to theta, then the other angle must be also equal to theta because they are equal to each other. Okay. So, all the things that I did in this second method, we have already done in the first method. Now, we'll start the second method actually. It will be different from the first method. In the second method, we'll do another construction. We will extend side OB and side AC by a straight line until they intersect with each other. Okay, here. And we will define the intersection point of the extended side OB and the extended side AC as E. Actually, we created here right triangle AOE. In the right triangle AOE, AP is angle bisector. Okay? And we have actually the angle bisector theorem. According to the angle bisector theorem, we'll get that if we have a triangle ABC, that could be any triangle, and here AD is angle bisector, that is to say, it bisects angle BAC into two halves, each half equals to theta. Then, according to angle bisector theorem, the following relationship exists between the parts of this triangle. Here, AB over AC equals to BD over DC. I repeat again that according to angle bisector theorem, if we have this triangle ABC, that could be any triangle, and here AD is the angle bisector of angle BAC. It bisects angle BAC into two halves, each half equals to theta. Then the following relationship exists between the sides of this triangle ABC, here between the parts of triangle ABC. That is to say, here AB over AC equals to BD over DC. So we can implement angle bisector theorem in our right triangle AOE, because of the fact that AP is angle bisector of angle OAE. Okay? So I'll copy the right triangle OAE in a new page, and we will implement the angle bisector theorem in this right triangle OAE. In the right triangle OAE, this is the right triangle AOE. And AP is the angle bisector. This angle equals to theta, and this angle also equals to theta. So according to the angle bisector theorem in the right triangle AOE, we will get that this will be equation number 1. AO over AE equals to OP over PE. Okay, so here again, here AO over AE equals to OP over PE, according to equation number 1. Here OP equals to 3 units. This is the radius of the semicircle. As you can see here, OP equals to 3 units. So AO equals to 6 units. It is the radius of the quarter circle over AE. 6 over AE, according to equation number 1, equals to OP. OP is 3, so we substitute OP by 3 over PE. Here we multiply equation number 1 by AE, and we will divide it by 3, and we will get that according to equation number 1, 6 over 3 equals to AE over PE. Here 6 over 3 is 2, so we get that 2 equals to AE over PE. We multiply this equation number 1 by PE, and we get that according to equation number 1, 2 times PE equals to AE. So AE equals to 2 times PE. So here we will define PE as A. PE equals to A according to our definition. And from equation number 1, we will get that AE will be equal to 2 times PE. A equals to 2 times PE. And PE is A, so A equals to 2A. So PA equals to A, and A equals to 2A. So we can write here that AE equals to 2A, and here PE equals to A. In the next step, we will implement the Pythagoras theorem on the right triangle AOE. Okay, so I'll copy the right triangle AOE again. And we will will implement the Pythagoras theorem on the right triangle, triangle AOE. We have already found out that AE equals to 2A, AO equals to 6, so what is the length of OE? Here OE equals to OP plus PE. Again, OE equals to OP plus PE. Okay, so OE equals to OP, that is 3 units, this is the radius of the semicircle, plus PE, that is A. So in conclusion, we found out that O equals to 3 plus A. Okay, now we can implement the Pythagoras theorem in the right triangle, triangle AOE. Okay, by PT, it is a relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, in the right triangle AOE, we will get the square of the hypotenuse is AE squared. This will be equation number 2. AE squared equals to the sum of the squares of the perpendiculars equals to AO squared plus OE squared. Okay. We have already found out that AE equals to 2A, so AE squared will be equal to 2A squared. And it is equal to AO squared. AO equals to 6, so AO squared is 6 squared, that is 36, plus OE squared. OE equals to 3 plus A, so OE squared will be equal to 3 plus A squared. So here we'll open the brackets on both sides of equation number 2, and we'll get that here 2A squared is 4A squared equals to 36, plus 3 plus A squared is 3 squared, that is 9, plus A squared plus 6A. Here 36 plus 9 is 45, so write it down. 4A squared equals to 45 plus A squared plus 6A. We subtract A squared from this equation, equation number 2, and we get that 4A squared minus A squared is 3A squared. It is equal to 45. A squared will get cancelled, plus 6A. We will divide this equation, equation number 2, by 3, and we get that according to equation number 2, A squared equals to 15 plus 6 over 3 is 2. 2, but here it is 6A over 3 is 2A. It is 6A over 3, that is 2A. Here we subtract 15 and 2A from this equation, equation number 2, and we get that according to equation number 2, A squared minus 2A minus 15 equals to 0. Okay, so here the coefficient A in this quadratic equation is 1. The coefficient B is minus 2. And the coefficient C is minus 15. And the general formula for a quadratic equation, to solve a quadratic equation, is AX squared x equals to minus b plus minus square root of b squared minus 4 times AC over 2A. This is the general formula that we always use in order to find out the variable missing in a quadratic equation. And the variable missing in our specific quadratic equation is A, x equals to A. So we'll put the data inside the equation for x and we found out the value of A, because x equals to A. So here x that is equal to A equals to minus B, B equals to minus 2, so minus B is minus 2, that is 2, plus minus square root of B squared. B equals to minus 2, so B squared is minus 2 squared, that is 4, minus 4 times A is 1, times C, that is minus 15, over 2A. 2 times 1 is 2, so here A equals to 2 plus minus, inside the root we have minus 4 times minus 15 is 60, and 60 plus 4 is 64. So inside the root what is left is only 64 over 2. So here we found out that A equals to 2 plus minus, the square root of 64 is 8 over 2. So here we will have two solutions that are possible for A. The first solution for A is A1 equals to 2 minus 8 over 2. 2 minus 8 is minus 6, and minus 6 over 2 is minus 3. So the first solution A1 equals to minus 3. But here we know that A is the length of side PE, and A as a length, it must be a positive number. A is a length, therefore it must be a positive number. Okay, it must be a positive number. Therefore, A can never be equal to minus 3, that is negative number. So we cancel the solution, and we left only with the second solution. At A2 equals to 2 plus 8 over 2. 2 plus 8 is 10, and 10 over 2 is 5. So I found out that A2 equals to 5. So here A equals to 5. So right here that A equals to 5. Therefore 2A will be equal to 10. And here actually, what is the length of line segment BE? From the drawing it is very easy to see that PE minus PB equals to BE. PB PB or PE minus PB equals to BE. I'll repeat again. From the drawing it is very easy to see that PE minus PB equals to BE. So BE equals to PE, that is 5 units, minus PB, that is 3 units. 5 minus 3 is 2, so PE equals to 2 units. B equals to 2 units. You can write here that B equals to 2 units. And what is the length of CE? For the drawing, it is very easy to see that CE equals to AE minus AC again. AE minus AC equals to CE. I will write it down. AE minus AC equals to CE. AE minus AC equals to CE. A equals to 10 units. AC is the variable that we are looking for, it is equal to X. So in conclusion, we found out that CE equals to 10 minus X. So we can write here that CE equals to 10 minus X. In the next step, we'll complete the quarter circle to a circle. So we completed the quarter circle to a circle, and we will extend line segment BO by a straight line until it touches the circle and we will define the touching point of the extended line segment BO and the circle as M. M is the touching point of the extended BO and the circle. Okay, so what is the length of MO? O is the center of the circle and also the center of the quarter circle. M is the point of the circle itself, and this is exactly the definition of a radius. That is to say, MO is the radius of the circle, that is also the radius of the quarter circle, that is equal to 6 units. According to what is given as the question. Okay, in the next step I will present to you a new rule. So if we have this circle, and from the external point, point P, we will draw 2 chords to this circle. So here the first chord is called this is called AB, and from point P we will draw a second chord to this circle. The second chord is CD. Then, according to this rule, that will be rule number 3 maybe. So here, according to this rule, the following relationship exists between the parts of the 2 chords. Here PA times PB equals to PD times PC. I repeat again, whenever you draw 2 chords to a circle from an external point of this circle, then according to this rule, PA times PB equals to PD times PC again. PA times PB equals to PD times PC. We can implement this new rule in our drawing. Okay? We have the external point, point E. From the external point, point E, we have 2 chords to this circle. The first chord is called EA and the second chord is called EM. So according to the rule that I mentioned, we will get that EC times EA, EC times EA equals to EB times EM. I repeat again, according to rule number 3 that I mentioned, in this drawing, EC times EA equals to EB times EM. Again, EC times EA equals to EB times EM. Okay? EC equals to 10 minus x, we substitute EC by 10 minus x. EA equals to 10, we substitute EA by 10, and it is equal to EB. EB is 2 units, we substitute EB by 2, and EM, the big, the long line segment EM equals to 6 plus 3 plus 3, that is 12, plus 2, that is 14. So in conclusion, we found out that EC times EA equals to EB times EA, to EB times EM, and it is equal to 10 minus x times 10 times that, and it is equal to 2 times 14. 2 times 14 is 28, and it is equal to 10 times 10 minus x. Here we will divide this equation by 10, and we will get that 10 minus x equals to 2.8. We will add to this equation x and we will subtract 2.8, and we will get that according to this equation x equals to 10 minus 2.8, that is 7.2. So we found out that x equals to 7.2 units. So in both methods, we found out that the length of line segment x equals to 7.2 units. Again, the length of line segment x that is actually equals to AC equals to 7.2 units in both methods. So in the next step, I will summarize the lecture. We'll start with the first method. I repeat on the question. We have here a semicircle inside the quarter circle. AO equals to 6 units, and we want to find out the length of side AC that is equal to x. Okay, so we defined the point of tendency of tangent AC with this semicircle as point D. We defined the center of this semicircle as point P. And then actually AO is the radius of the quarter circle because of the fact that it starts from the center of the quarter circle, and line segment AO ends at point A. It is a point on the quarter circle itself, and this is exactly the definition of a radius. So AO is the radius of the quarter circle that is equal to 6 units. Therefore, OB is also the radius of the quarter circle that is equal to 6 units. O is the center of the quarter circle, and this angle OAB, AOB equals to 90 degrees because of the fact that this is a quarter circle. This angle must be equal to 90 degrees. Angle OB must be equal to 90 degrees. We join points A and P together by a straight line, and here we join points P and D together by a straight line, and here OB is the radius of the quarter circle, but OB is the diameter of the semicircle, and the diameter is twice as large as the radius. So if the diameter equals to 6 units, if the diameter of the semicircle equals to 6 units, it means that the radius must be equal to half of it, that is 3 units. So OP equals to 3 units, PB equals to 3 units, and PD also equals to 3 units. All those line segments are the radii of the semicircle. Then I presented to you rule number 1. According to rule number 1, the lengths of two tangents from a common external point to a circle are equal. So here we have the external point P. From point P we draw two tangents to this circle, tangent PA and tangent PB. And according to rule number 1, the lengths of two tangents, that is to say the length of the first tangent is PA, the length of the second tangent is PB, from a common external point, that is to say from point P to a circle to points A and B, are equal. That is to say, the first tangent PA is equal in its length to the second tangent PB. So whenever you draw two tangents to a circle from a common external point to that circle, then the lengths of those two tangents will be equal to each other. In this case, PA equals to PB. So we can implement rule number 1 in our drawing. In our drawing we have the common external point A. From the common external point A we have the first tangent to the semicircle, that is AO. The point of tangency is tangent O. And the second tangent to this semicircle is AD, and the point of tangency is point D. And according to rule number 1, the lengths of those two tangents that exiting from a common external point must be equal to each other. That is to say, AO equals to AD according to rule number 1. Okay, here AO equals to AD according to rule number 1. But according to what is given us in the question, AO equals to 6 units. Here AO equals to 6 units. So from this equation, 6 equals to AO equals to AD, we will derive that AD is also equals to 6 units. Okay, then we actually proved that those two right triangles can go into each other according to side rule. Triangle AOP can go into triangle ADP according to side rule. Here side AO equals to side AD equals to 6 units. OP equals to PD equals to 3 units. This is the radius of the semicircle. And AP is the common side that belongs to both triangles. Therefore, those two triangles can go into each other according to side rule. Triangle AOP can go into triangle ADP according to side rule. And from the fact that those two triangles can go into each other, we will derive that those two angles are equal to each other. Okay, here angle OAP, this angle equals to angle PAD. Okay, and if we define one angle as theta, then the other angle must be also equal to theta, because of the fact that those two angles are equal to each other. Okay, so those two angles are both equal to theta. Then we focused on triangle AOP. In this triangle AOP, we know that tangent theta equals to OP over OA. Tangent theta equals to OP over OA. OP equals to 3 units. OA equals to 6 units. So tangent theta equals to 3 over 6, that is 1 over 2. In conclusion, found out that tangent theta equals to 1 over 2. Then I presented to you the law of cosines, and we implemented the law of cosines. Actually, we connected together points O and C by a straight line, and we implemented the law of cosines in the great triangle, triangle AOC. First of all, what is the law of cosines that I have already mentioned in the previous lecture? If we have triangle ABC, that could be any triangle. Side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is theta. Then according to the law of cosines, we get that C square equals to A square plus B square minus 2 times A times B times cosine theta. Okay, then we implemented the law of cosines in the great triangle, triangle AOC. This great triangle, triangle AOC. So I copied the great triangle, triangle AOC in a new page, and we implemented the law of cosines in this triangle, triangle AOC. This is triangle AOC. AO equals to 6 units according to what is given as the question. OC, O is the center of the quarter circle. C is the point of the quarter circle itself, and this is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to 6 units. So OC equals to 6 units, and AC is the line segment that we are looking for in this question. AC equals to X. This is the line segment that we are looking for in this question. Okay, so AC equals to X. And the angle OAD equals angle OAC. This angle equals to 2 theta. OAC equals to 2 theta. Then we implemented the law of cosines in this triangle, triangle OAC. According to the law of cosines, OC square equals to AO square plus AC square minus 2 times AO times AC times cosine 2 theta. OC square equals to AO square plus AC square minus 2 times AO times AC times cosine 2 theta. OC equals to 6, so OC square is 6 squared, that is 36. AO also equals to 6, so AO square will be also equal to 36. AC equals to X, so AC square is X squared. Minus 2 times AO is 6, and AC is X, so it is minus 2 times 6 times X times cosine 2 theta. Here we have 36 on both sides of equation number 1, so 36 will get cancelled. And what is left after we cancel 36 is from equation number 1? What is left here? In this side we have 0, on the other side we have x squared minus 12x cosine 2 theta. We added 12x times cosine 2 theta to this equation number 2, and we got that equation number 1, and we got that according to equation number 1, x squared equals to 12 times x times cosine 2 theta. We divided this equation number 1 by x, and we found out that 12 times cosine 2 theta equals 2x. Okay? According to equation number 1, 12 times cosine 2 theta equals 2x. And so the only thing that is left to find is to find out the value of cosine 2 theta. In order to find out the value of cosine 2 theta, we have the trigonometric identity that states that cosine 2 theta equals to 1 minus tangent square theta plus over cosine 2 theta equals to 1 minus tangent square theta over 1 plus tangent square theta. Okay, and we already found out that tangent theta equals to 1 over 2. So we can substitute tangent theta in this trigonometric identity by 1 over 2. We did it, and we got that cosine 2 theta equals to 1 minus tangent square theta. Tangent theta equals to 1 over 2, 1 half. Therefore, tangent square theta will be equal to 1 half squared, that is 1 over 4. 1 over 4 over 1 plus tangent square theta, and tangent square theta equals to 1 over 4. So conclusion found out that cosine 2 theta equals to 1 1 over 4 over 1 plus 1 over 4. 1 minus 1 over 4 is 3 over 4, and 1 plus 1 over 4 is 5 over 4. We have 5 in the numerator, we have 4 in the numerator and 4 in the denominator, so 4 will get cancelled, and we left only with 3 over 5. So in conclusion, we found out that cosine 2 theta equals to 3 over 5. Now we can substitute cosine 2 theta in equation number 1 by 3 over 5. We did it, and we got that according to equation number 1, 12 times cosine 2 theta equals 2x. So we can substitute cosine 2 theta by 3 over 5. We did it, and we got that 12 times cosine 2 theta is 3 over 5, that is equal to x. 12 times 3 is 36, and 36 over 5 is 7.2. So in conclusion, we found out that x equals to 7.2 units. So this 9 segment AC that is equal to x, it is equal to 7.2 units. We finished with the first method. Then I actually presented to you how to find out the length of line segment x according to the second method. In the second method, we used all the things that we have already found out in the first method. We've already found out that those two triangles, triangle AOP, can go into triangle ADP according to side rule. And from the fact that those two right triangles can go into each other, again here, triangle AOP can go into triangle APD according to side rule, and from the fact that those two triangles can go into each other, we conclude that angle OAD equals to angle PAD. So if one angle equals to theta, then the other angle will be also equal to theta because of the fact that they are equal to each other. So both those two angles are equal to theta. Then I presented to you, but before that we extended the line segment AC by a straight line, and we also extended line segment OB by a straight line until they intersect with each other at point E. And in this way we created the right triangle AEO. In this right triangle AEO, we have side AP, line segment AB that is angle bisector. This angle bisector of angle OAE, that is to say divides angle OAE into two halves. Each half equals to theta. And we have the angle bisector theorem that, according to angle bisector theorem, if we have this triangle ABC, that could be any triangle, and we have line segment AD, that is angle bisector of angle BAC, then according to angle bisector theorem, we will get that AB over AC equals to BD over DC. Again, AB over AC equals to BD over DC. So we can implement angle bisector theorem in the right triangle AOE. In this right triangle, I copied the right triangle AOE from the original drawing. This is the right triangle AOE. This angle equals to 90 degrees. Those two angles are equal to theta. AP is angle bisector of angle OAE. And AO equals to 6 units. OP is the radius of the semicircle that is equal to 3 units. So according to angle bisector theorem, we get that AO over AE equals to OP over PE. Again, AO over AE equals to OP over PE. This is equation number 1. AO equals to 6. AE is AE. P OP equals to 3. So we substitute OP by 3 over PE. Then we divided this equation by 3 and we multiplied it by AE, and we got that 6 over 3 equals to AE over PE. 6 over 3 is 2, So 2 equals to AE over PE. We multiply this equation by PE and we got that AE equals to 2 times PE. So we defined PE as A. Here, PE equals to A according to our definition. And therefore, according to equation number 1, that A equals to 2 times PE and PE equals to A. Therefore, according to equation number 1, we get that A equals to 2 times A. A equals to 2 times A or 2A. A equals to 2A. And P equals to A. Okay. Then we implemented the Pythagoras theorem on triangle, the right triangle AOE. We have already found out that A equals to 2A. Equals to 2A according to equation number 1. What is the value of OE? OE equals to OP that is 3 plus PE that is A. O equals to 3 plus A. O equals to 3 plus A. And AO equals to 6 units according to what is given us the question. Okay. Then we implemented the Pythagoras theorem on this right triangle, triangle AOE. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the square of the hypotenuse is AE squared, and it is equal to AO squared plus OE squared. A equals to 2A, so A squared is 2A squared. AO equals to 6, so AO squared is 6 squared, that is 36, plus OE squared. OE equals to 3 plus A, so OE squared is 3 plus A squared. We open the brackets on both sides of equation number 2, and regard that according to equation number 2, 2A squared is 4A squared. It is equal to 36 plus 3 plus A squared. 3 plus A squared equals to 3 squared, that is 9, plus A squared plus 6A. So here we have 4A squared, 36 plus 9 is 45, plus A squared plus 6A. We have here, we subtracted A squared from equation number 2. 4A squared minus A squared is 3A squared, and it is equal to A squared. Here A squared will get cancelled, plus 6A. We divided equation number 2 by 3, and we got that 3 times A squared over 3 is A squared, 45 over 3 is 15, plus 6A over 3 is 2A. So in conclusion, we found out that according to equation number 2, A squared equals to 15 plus 2A. We subtracted 15, and also 2A from this equation number 2, we got the quadratic equation that A squared minus 2A minus 15 equals to 0. Here the coefficient A equals to 1, the coefficient B equals to minus 2, and the coefficient C equals to minus 3 in this quadratic equation, and the variable that we are looking for in this quadratic equation is A, so x equals to A. And the general formula for a quadratic equation to find out the variable that we are looking for in the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. And x in our specific quadratic equation equals to a. A is the variable that we are looking for. So we put the data inside the formula for x, and we found out the value of a because x equals to a. So here, according to this formula, x equals to minus b. B equals to minus 2, so minus b is minus 2, that is 2, plus minus square root of b squared. B equals to minus 2, so b squared is minus 2 squared, that is 4. Minus 4 times a is 1, and c is minus 15. So over 2a, a is 1, so 2 times 1 is 2. So in conclusion, we found out that a equals to 2 plus minus. Here inside the root, we have minus 4 times minus 15 is plus 60, and 60 plus 4 is 64. So inside the root, we left only with 64, and we got that a equals to 2 plus minus square root of 64 over 2. The square root of 64 is 8, so here we will have two solutions that are possible for a. the first solution is A equals to, here we have the two solutions that are that is A equals to 2 plus minus 8 over 2. We have here two solutions. The first solution is A1 equals to 2 minus 8 over 2. 2 minus 8 is minus 6, and minus 6 over 2 is minus 3. But because of the fact that A is the length of side PE, it must be a positive number. Therefore, A can never be equal to a negative number, so we cancel this solution, and we left only with the second solution. A2 equals to 2 plus 8 over 2. 2 plus 8 is 10, 10 over 2 is 5. So in conclusion, we found out that A2 equals to 5. So we can write here that PE equals to A, that is equal to 5, and A equals to 2A. 2 times 5 is 10, so A equals to 10, P equals to 5, and here we know that P equals to 5, PB equals to 3, so BE will be equal to PE minus PB. Okay, BE, here, BE equals to PE minus PB. Okay, again, BE equals to PE minus PB. PE equals to 5 units, PB equals to 3 units. So in conclusion, B equals to 5 minus 3, that is 2 units. Here, B equals to 2 units, and here B equals to 2 units. So what is the length of CE? From the drawing, it is very easy to see that CE equals to AE minus AC. Again, CE equals to AE minus AC. AE is 10 and AC is X. So in conclusion, I found out that C equals to X minus 10. Then I presented to you a new rule that is actually rule number 3. If we have this circle, and from the external point P, we draw 2 chords to this circle. The first chord is called AB, and the second chord is called DC. Then the following relationship exists between the parts of those 2 chords. Here, PA times PB equals to PD times PC. Again, PA times PB equals to PD times PC. So we can implement this new rule, rule number 3, in our drawing, because in our drawing we have the external point E from the, first of all, we completed the quarter circle to a circle. And then we extended line segment BO until it touches the circle at point M by a straight line. MO is the radius of the quarter circle because of the fact that it starts from the center of the quarter circle and also the center of the circle and ends at point M. That is the point on the circle itself, and this is exactly the definition of a radius. Therefore, MO is the radius of the quarter circle and also the radius of the circle that is equal to 6 units. Okay, now we can implement rule number 3 in this drawing, because from the external point E, we have the first chord is EA and the second chord is called EM. Or from point E, we have chord CA and chord BM. Okay, so according to rule number 3, we will get that EC times EA, again EC times EA equals to EB times EM. Again, EC times EA equals to EB times EM according to rule number 3. Okay, here EC times EA equals to EB times EM according to rule number 3. EC equals to 10 minus x. EA equals to 10, EB equals to 2, and EM equals to, what is the value of EM? EM, the big line segment EM equals to 6 plus 3 plus 3, this is 12, plus 2 is 14. So EM equals to 14. We substitute EM by 14. In conclusion, we found out that 10 minus x times 10 equals to 2 times 14. 2 times 14 is 28, so here we have 10 times 10 minus x equals to 28. We divided this equation by 10, and we got that 10 minus x equals to 28 over 10 is 2.8. We added x to this equation. Here we added x to this equation, and we subtracted 2.8, and we found out that x equals to 10 minus 2.8, that is actually 7.2 units. So in conclusion, we found out that the length of line segment AC that is equal to x equals to 7.2 units in both methods. Okay, thank you very much.